Welcome to the last radical edition of Comet Algebra. This video is for Algebra 2, Chapter 7, Section 6, Solving Radical Equations. This is also for Section 7, so it's just the last radical video. I know you're very, very sad about that. In this video, we're going to talk about how to solve these equations, and we're going to follow these steps. First, you need to isolate the root, which could be square root, cube root, whatever. Isolate the root with the variable on one side of the equation. And then you raise both sides of the equation to that power. If it's a fourth root, you raise it to the fourth power. Cube root, you raise it to the third power, and so on. And then please be careful about checking for your, I call them garbage answers. Sometimes the algebra is correct and it gives us an answer, but because of the nature of roots, when they exist and when they don't, when a negative root exists, sometimes the answers are garbage, so we got to watch out for those. So let's look at this first example where step 1 says to isolate the radical. We'll start by adding a 2 to both sides. Over here we get 12. And then to isolate the radical, we need to get rid of this times 3, so we're going to divide both sides by 3. So then we finally have the radical alone. Square root of x plus 4 is equal to 4. And since this is a square root, we are going to square both sides. When you square a square root, all that's left is what's underneath. So I have x plus 4 is equal to 16. And then if we subtract a 4 from both sides, we get x equals 12. And then we do want to check this answer. And perhaps you can do this mentally, but I just plugged in the 12 for the x here so we can look at it. 12 plus 4 is 16. Square root of 16 is 4. So I have 3 times 4, which is 12, minus 2, which is indeed 10. 10 equals 10, so this checks out. Okay, in this next example, we have x to the 1/4 power plus 5, so we need to get rid of that plus 5 right away. And you can leave this as x to the 1/4 power, or you can write this as the 4th root of x, whatever you prefer. But either way, this equals a negative 2, and we need to raise both sides to the 4th power to get rid of our radical. So we end up with x equals, and negative 2 to the 4th power is 16. And so once again, we want to check and make sure our solution is correct. So let's take this 16 and put it in for x. 16 to the 1/4 power is the same as writing the 4th root of 16. And then we're going to add 5 to that and see if we get 3. And the 4th root of 16 is 2, because 2 times itself 4 times is 16. And sorry to say, in this case, it does not check out. So we're going to have to throw this out, and even though our algebra was right, this equation has no solution. And we might have recognized that way back right here when we had an even root and we were supposed to get a negative number, but so no solution. The last type of exponential equations we're going to solve is when the variable is stuck up here in the exponent. Now, right now, our skills are only going to be limited how we can solve these, but once we complete the logarithm chapter, we'll be able to solve many more of these. For right now, we need to follow these steps and change both sides so that they have like bases. And if we can't do that, we can't solve it yet. So for right now in this chapter, we should be able to change them to like bases. And if the bases are equal, the exponents are equal. And so we'll be pulling out the exponents and setting them equal to each other. So we're looking at our numbers. We have a 4 and a 32. Since 4 can be written as a base 2 number, 4 is 2 squared. So we have 2 squared, and we're raising it to the x power. So now if we can write 32 as a base 2 number, we're in business. Otherwise, we cannot proceed. And if we check, the 32 can be written as 2 to the 5th power. So I'm just going to simplify this exponent a bit. When we have a power raised to a power, we multiply exponents. So I can write this as 2 to the 2x equals 2 to the 5th. Now I don't know if you caught when I said it earlier, but what I said is if the bases are equal, and these are set equal to each other, that means their exponents have to be equal. So you can take them and just pull them out of here and write a separate equation. So we can pull out the 2x and pull out the 5 and then solve this to get x is equal to 5/2. And you can check that if you'd like. If you would take 4 to the 5th power, you'd get a big number, and then if you took the square root of that, because remember, when you have a fraction in your exponent, this top number is the exponent, and this bottom number is the root. All right, in this last example, quite obviously the base would have to be a 5, so 25 can be written as 5 squared, and then it's 5 squared to the x power, so it's 5 to the 2x. And 125 is 5 to the 3rd power, so I'll put that down here in the denominator. Now we need to make these like bases, so if you remember, we flip an exponent when it's negative in order to make it positive. Well, we can do the vice versa of that. You can flip this 5 to the 3rd up here to the numerator, but if you do flip it up, then that positive 3 becomes a negative 3. So just think about that for a minute. If you flip a negative exponent down to make it positive, the vice versa of that is also true. So now once again, if the bases are the same, their exponents are equal. So we can pull these out. 2x is equal to negative 3, so x is equal to a negative 3/2. And that's how we solve, for right now anyway, that's how we solve when the x is tucked up in the exponent. All right, now you have the knowledge you need to finish up chapter 7, so have a radical time with that.